Welcome to the project demonstration for the Texas Instruments Innovation Design Challenge 2015 by Team 905 from the National Institute of Technology, Karnataka, Surathkal. Our project implements a fire detection and evacuation planning system using carbon monoxide sensors. Every year, over 30,000 fire-related casualties are reported. Fire damages account for nearly 444 crore rupees of losses each year in India and over $15 billion globally. Our project seeks to mitigate these losses by attaining the following objectives. First, to detect fires and notify fire response teams immediately. Second, to provide information about the origin of the conflagration. To indicate dangerous zones in the building for formulation of viable escape routes. And lastly, to relay information about the extent and condition of the fire periodically. The MQ7 sensor has a stannous oxide layer whose resistance decreases with increase in carbon monoxide concentration. This property is used to calibrate the carbon monoxide concentration in the atmosphere. A pair of XPs are then used to wirelessly communicate between the slave MSP that carries the sensor circuit and the master MSP that is linked to the GSM module. XCTU protocol is used to configure the XPs by matching the PAN IDs and the MAC addresses. Communication between two MSPs is achieved through I2C communication. Serial clock lines and serial data lines of both are connected together and pulled up using resistors to drive them high in the absence of any signal. The GSM module, in this case the SIM300, sends an SMS to the fire department alerting them of a possibility of fire and giving them details about the location. The IC MAX232 is then used to interface it with the MSP. Let's now take a look at a video demonstration of our project.
This is the slave circuit. The slave circuit consists of a carbon monoxide sensor MQ7 that is connected between 5 volts and ground. The sensor output is given to the analog pin A3. The microcontroller reads the carbon monoxide concentration in terms of voltage from the sensor. There is a potential divider circuit here which corresponds to the change in concentration and maps it to a voltage change in the controller. The controller sends the analog value byte-wise to the ZigBee. The ZigBee transmits the values to the master, which is accompanied by a ZigBee module as well. The values that are sent from the master to the slave are mentioned along the serial monitor. This is the master circuit. It consists of MSP430, the receiver ZigBee, and a SIM300 GSM module. The master MSP receives the sensor data from the receiver ZigBee. The SIM300 also requires UART pins for transmission and reception, and since the master MSP's UART pins are already occupied by the ZigBee, we transmit the data from the master MSP to another MSP through I2C protocol. The MSP's 3 volt logic level is incompatible with the SIM300's 5 volt logic level, so we use the IC MAX232 to interface the MSP with the SIM300.
The serial monitor is showing the values which are read by the carbon monoxide sensor as seen at the master MSP under normal atmospheric conditions. The value is approximately close to 0.5 volts. We now burn a piece of paper near the carbon monoxide sensor to increase the concentration of carbon monoxide. Due to the increased concentration of carbon monoxide near the sensor, the values observed in the serial monitor are continuously increasing. When the values increase above a voltage of 1.5 volts, the master instructs the GSM module SIM300 to send an SMS to the fire station alerting them about the possibility of a fire. This is the message that has been received. The message is as follows: fire alert, concentration of carbon monoxide about 3000 ppm, and it has sent the coordinates of the sensor.
This project can be expanded by extending the sensor network in large apartment buildings to pinpoint fires more accurately. Thank you for watching.